Okay. Go ahead, Aurélien. Sorry.
Okay, so for the newly recording people, so we are going to enable the reporting of errors during MPI init, before MPI init, during MPI finalize, and after MPI finalize. So we have to define how we return these errors to the users and how they can control the behavior of the error reporting before and during MPI init. So a side goal of this work is to be able to use things like the info object before MPI init. So this is not part of this pull request. This is something that comes separate or is totally independent in some respect. But we are striving to provide some sound failure handling or error handling for this function if they are called before MPI init. So we explore the different number of ways for doing this. The current way what we are proposing is to have set a default error handler that is set to info keys that are passed to the spawning operation, so the MPI spawn or the MPI exec. And the change since the December meeting is that this default error handler is now independent of MPI self, which might not exist before MPI init. All right, so we tried all these other things. They had problems. They've been discussed in the past. If you want more info, I can go back to it. But let's focus on what we are doing today. So the list of changes is not that big. So we had the notion of an initial error handler. The initial error handler is set and only set by info keys that are passed to MPI spawn on MPI exec. The initial error handler is called before or during MPI init and after MPI finalize, and it is associated to the default. It is associated by default to the predefined communicators, world, self, and get parent. So because we are going to return errors, we need to be able to understand what they mean. So we have error strings on error class that are called before and after MPI init and are thread safe. And we also have a bunch of minor clarifications because the term default error handler already appeared somewhere else. So we wanted to make sure that there was no confusion here. And there's also in this ticket a clarification about what it means for MPI finalize if some processes are not calling MPI finalize because they encountered an error or a failure, and what it means that there are failed processes for the rank 0 that has to always return from the errors. So that's it for the general description. And now I will move on to the text itself, if that's okay with people. So is the text big enough here?
Yeah, that's fine.
Okay. All right, so the first piece of text that's modified. So if you want to follow along, you can show the highlights or notes in your PDF reader, and that will bring you directly to the changes. And then the changes are LaTeX diff generated, so the new text is blue, the red text is removed in red, and disappears in these footnotes there. Okay, so the first text that we modify is in the terms and definitions. And we clarify what are the error classes that we are talking about in general in MPI. And so we clarify that MPI does not provide mechanism for dealing with transmission failures, which is a new term that is defined in the term index. And then we keep the whole text. If the MPI implementation is built on an unreliable underlying mechanism, then it is the job of the implementer to insulate from this unreliability and to reflect only unrecoverable transmission failures. Okay, similarly, MPI itself provides no mechanism for handling MPI process failures. That is, when an MPI process unexpectedly and permanently stops communicating, e.g. a software or hardware crash results in an MPI process terminating unexpectedly. So that is also a new term that appears. MPI process failures is a new term that appears in the index. Okay, so we go further along in this text that describe what are the capabilities of MPI when there are failures, when there are errors. Okay. We'll start reading the text from here. All right, now I will start reading the text from here. So on the other hand, some errors may be detected after the associated operation has completed. Some errors may not have a communicator, window, or file on which an error may be raised. In such cases, these errors will be raised on the communicator MPI-COM self. When MPI-COM self is not initialized, that is before MPI-init, MPI-init thread, or after MPI finalize, the error raises the initial error handler set during the launch operation, and C with a forward reference to that point. Okay, that was all for it, for here. So we go now further away in the general description of error handling capabilities. So this is where we define all the functions for creating or managing error handlers. So a user can associate, I'm starting from here, a user can associate error handlers to 3 types of objects, communicators, windows, and files. The specified error handling routine will be used for any MPI exception that occurs during a call to MPI for a respective object. MPI calls that are not related to an object are considered to be attached to the communicator MPI-COM self. When MPI-COM self is not initialized, that is before MPI-init, MPI-init thread, or after MPI finalize, the error raises the initial error handler set during the launch operation. So the next difference here, we capture a missing instance of MPI processes. So that's a minor thing that doesn't really relate to what we're doing here, but anyway. All right, so let me see if I can show you. No, it doesn't matter. Okay, so here we define what is the default error handler on predefined communicators. So unless otherwise requested, the error handler MPI errors are fatal is set as the default initial error handler and associated with predefined communicators. Okay, so now we are in the definition of MPI error string. And we add to the definition of MPI error string a piece of text that has been copied from another one of these functions that can be called before MPI-init. It is one of the few routines that may be called before MPI-init is called. This function must always be thread safe as defined in section 12.4.
Should those 2 sentences be the other way around? It doesn't. I mean, I don't disagree with either of them, but I think it just reads better if it's first said this function something something and then it is, rather than what does the it refer to in the first sentence.
I see. Sure. Let me. So yeah, this text is copied from somewhere else. So okay.
I suspect that somewhere else it had a previous sentence.
It might have a back reference to relate to indeed, yes. Okay, so let me see. So invert these 2 sentences. So that's 73.
Go make a comment on the pull request so we can keep track of it.
Thank you. So we will have the here we don't have that problem. The function MPI error class maps each standard error code error class onto itself. It is one of the few routines that may be called before MPI-init is called. This function must always be thread safe as defined in section 12.4. That's the same text again. So okay, let me move out of order here so that we understand what we're talking about before we go back to the little details. Okay, so we're in the definition of MPI-init, and in MPI-init we add MPI error class, MPI error string to the list of functions that can be called before MPI-init. So the only MPI function that may be invoked before MPI initialization are MPI get version, get library version, initialize, finalize, error class, error string on the MPI it is. Okay, so now we discuss what's happening when there is an error during MPI init. Failures may disrupt the execution of the program before or during MPI init. A high-quality implementation shall not deadlock in MPI init, even in the presence of failures. Errors prior or during MPI init are reported by invoking the initial error handler. Users can use the MPI initial error handler info key during the launch operation, e.g. MPI conspawn, MPI conspawn multiple, or MPI exec, to set a non-fatal initial error handler before MPI init. When the initial error handler is set to MPI errors abort, raising an error before or during initialization aborts the local MPI process. That is, it is similar to calling MPI abort on MPI conself. An implementation may not always be capable of determining before initialization what constitutes the local MPI process or the set of connected processes. In this case, errors before initialization are treated as fatal on a best effort basis. After initialization, the initial error handler is associated with MPI com world, MPI com self, and the communication returned by MPI com get parent, if any. Any question on this? Okay, no questions. So I will keep going with the advice that relates to that same thing, so we can still discuss this if you want. Some failures may leave MPI in an undefined state or raise an error before the error handling capabilities are fully operational, in which cases the implementation may be incapable of providing the desired error handling behavior. Of note, in some implementations, the notion of an MPI process is not clearly established in the early stages of MPI init. For example, when the implementation considers threads that call MPI init as independent MPI processes. In this case, during MPI init, the MPI error abort error handlers may be treated as fatal. So I let you process this. I know Dan had something to say about that, but
can you remember what it was that I was supposed to be saying? I can't remember it right now. I think that's fine to me.
Okay, so you were the one that raised the issue that before MPI init we might not be able to know what is the self process. So that's what.
Yeah, I think the current text, as you've just read it out, covers that possibility.
Okay. So that was the goal. Good. So I'm going to pass the second part of that advice here. We'll come back to it later after we're done, so that we do not get derailed, and we can discuss the rest of it. Okay, so here after MPI is initialized, why do we change this? I think that's just a glitch here based on the diff. There is no difference here. Okay, so in the MPI info env object, we add the MPI initial error handler, the name of the initial error handler. So that's one of the info keys, the info that are appearing in MPI info env.
So the word name there is appropriate because all of the ones that are allowed are named, as in they have names standardized in the MPI standard. Yes, you aren't allowed to use a user-defined one, so it's not a function name. Should that be made more explicit in that the only ones that you can pick are MPI errors abort, MPI errors are fatal, MPI errors return?
We'll talk about that later.
Okay, good.
So I'll get there. Actually, we might very well get there immediately. So let me remember, I need to go back to 401 and I need to go back to 405. Yeah, I think that's the place. Yeah. All right, so we're in the MPI, we are in the MPI exec section. So in the MPI exec section, we add the initial error handler parameter that matches the MPI-COM spawn info key. And here we are in MPI-COM spawn on MPI-COM spawn multiple. So there is quite a lot of text here, MPI-COM spawn multiple. And here we have a bunch of reserved keys that pertain to MPI-COM spawn and MPI-COM spawn multiple. Among these, we add MPI initial error handler. The value is the name of an error handler that will be set as the initial error handler. The MPI initial error handler key can take the case-sensitive, insensitive values MPI errors are fatal, MPI errors abort, and MPI error return, representing the predefined MPI error handlers. MPI errors are fatal, the default, MPI errors abort, and MPI error return, respectively. Other non-standard values may be supported by the implementation, which should document the resultant behavior. So I think that's covering what you were discussing before.
Yeah, so I guess the point is maybe that text should also appear in the other place, because one's applying to MPI exec and one's applying to COM spawn and spawn multiple. Actually, the text, the sense of the text applies in both cases, but it's clear here, it's not clear there. But then that's true for all of the others. So I'm sort of dubious about whether we should do that or not, because you'd have to copy all of this text about soft as well. And
yes, and so, okay. The way they deal with it in the existing text is that they say that the MPI exec parameters are basically equivalent to the info keys.
Mm-hmm. Okay.
So that's how they deal with that at the moment. So I think we're just tagging along here on the right. Okay, so let me go back to here now. So okay, so now we have defined everything that happens during MPI finalize, during MPI init. And now we are moving on to what happens during MPI finalize. So inside the definition of MPI finalize, we add to the list of functions that are valid after MPI finalize, MPI error class, MPI error string. And then we add this piece of text. Failures may disrupt the execution of MPI finalize. A high-quality implementation shall not deadlock in MPI finalize, even in the presence of failures. The normal rules for error handling continue to apply. After MPI-COM self has been freed, errors that are not associated with the communicator window or file raise the initial error handler set during the launch operation. See that paragraph that defines this. Okay. So note that a failure may terminate the MPI process that was assigned rank 0 in MPI-COM world, in which case it is possible that no MPI process returns from MPI finalize. So that relates exactly to the piece of text that's immediately above. We require that at least process 0 in MPI-COM world return. Obviously, if that process is dead, that's not happening.
In the previous piece of text, Aurélien, after MPI-COM self has been freed, is freed the right word there? Because freed could be just marked for being freed in the future, at which point you potentially could still use it for an error handler. What you mean is destroyed.
Okay, so let me verify. I think it is the correct word, but maybe you're right. Let's verify. Okay, so that should be somewhere in here where we say the call to MPI finalize. Okay, whatever. Where does it talk about MPI-COM self here? I think that will be here, allowing user function at process termination here. Okay. If you look at this text, this can be accomplished in MPI by attaching an attribute to MPI COM/self with a callback function. When MPI finalize is called, it will first execute the equivalent of MPI COM/free on MPI COM/self. This will cause the delayed callback functions to be executed on all the keys, etc., etc.
So yes,
the freeing of MPI COM/self occurs before any other parts of MPI are affected. So MPI finalize will return false during the callback, etc.
Yeah. Okay. So I guess there it is saying that the freeing, as in the process. So the process is called freeing, and by that it's fairly explicit there that it's actually going to go through the process of destroying it, calling callbacks and the like. Because I guess the equivalent of calling COM/free on a communicator isn't necessarily the same thing as destroying it. This text is then saying this will cause, well, yeah, at some point in the future it will cause, stuff to happen, delete callbacks and the like to happen. But it is still true in the COM/free definition that you can mark something for freeing in the future, and at some point something will happen. Or at least you're sort of led to believe that it will eventually, but that isn't necessarily part of the freeing, as in the call to MPI COM/free. I think there's a slight hair to split here, and I'm not really sure whether I care that much really.
Well, I'll take a note about it, and we'll think again about it. I'm not sure it matters that much, but let's make sure that we do it right.
I think it's reasonably clear what you intend in the text that you've read out. I think there's a difference between COM/free and COM/disconnect. And
yeah, the difference being that in COM/free you mark it for deletion. It's not necessarily done yet. It might be done later.
Yeah, and in disconnect you actually delete it. You actually destroy it and recover the resources, and disconnect all the other connected process and so on. You actually actively do something. And I think given that there is a difference between COM/free and COM/disconnect, this existing text mentions COM/free. It does not mention COM/disconnect, and so perhaps the right word is freeing and freed. So maybe I should just.
I think the pieces that makes this text very clear is that the freeing of MPI COM/self occurs before any other part of MPI are affected. So really, you have to actually free or destroy the MPI COM/self as the very first thing you do in MPI finalize. There is no choice here.
Yeah, but just reading this in isolation, I can sort of imagine an implementation where I push what finalize actually should do. All of the tasks are finalized onto another thread and then just return from finalize. Right? That would match this absolutely fine. The first thing I'm going to do on that other thread, whenever it gets scheduled sometime in the future, will be the equivalent of a COM/free and mess about with COM/self. Yes, sure. But in the meantime, I've returned from MPI finalize back to the code that called it. Right? I've not destroyed COM/self yet, but I will do. I promise I will do on this other thread.
No, I think that would be incorrect, but okay. It's a detail. It's not.
Yeah, detail. I think I don't care that much, but I'm just pointing out that maybe freed isn't the right word, because of the sense in this text, after COM/self has been freed, errors are not associated. When does that actually happen? It happens when when the error handler is disconnected from COM/self, which is part of the destruction of COM/self, not part of the necessarily freeing. It's a bit later. But yeah, I just move on, I guess.
Okay, so we are back at the case then. We are back at the case of rank 0 returning from MPI finalize. So we say that this is not always possible as a standard text, and then we explain to users why it is not always possible. Applications that handle errors are encouraged to implement all rank-specific code before the call to MPI finalize. In example 8.10 below, the process with rank 0 in MPI homeworld may have been terminated before, during, or after the call to MPI finalize, possibly leading to the code after MPI finalize never being executed. So that's the example in question. We do finalize. If my rank is 0, I do some file operations. So if rank 0 doesn't return, that code doesn't execute. What else do I have to show? Yes. So here we have a piece of text that says, that talks about erroneous programs that do not call MPI finalize. And so we had an advice to implementers. In practice, it may be difficult to distinguish between an MPI process failure and an erroneous program that terminates without calling MPI finalize. An implementation that defines semantic for process failures management may have to exhibit a behavior defined for process failures with such erroneous programs. A high-quality implementation should exhibit a different behavior for erroneous programs and process failures. Okay. So we are done with all of the meat of that proposal now. We are just ironing out the borders. And so there is a little bit of, so since we had the notion of the initial error handler, and there was a bunch of places where we're talking about default error handlers, I made a pass on it to make sure that we clarify what that means in all cases and there is no confusion. So in this MPI win call error handler, there is an advice to users that reminds that the error handler MPI errors are fatal is associated to window when it is created. The error handler MPI errors are fatal is associated to window when it is created. So that substitute to this text that says, as with communicator, the default error handler for Windows is. It is not really true that it is the same as communicators. Communicators inherit their error handlers from their parent, and the predefined get the communicator set from the initial error handler. So that was confusing. Now it is explicit what happens. But what happens has not changed. So we have the same piece of text here. So we are in the error handling section in the one-sided operations chapter. And so we rewrite slightly the text to say the same thing that was said before. The error handler MPI errors are fatal is associated with win. Win is referred to be a little bit above here. The error handler MPI errors are fatal is associated with win during its creation. So that substitute to the default error handler for win is MPI errors are fatal. And we have a similar piece of text for the IO error handlers. So the IO error handlers, they behave completely differently than the rest of the standard. Basically, they inherit the error handler that is set on MPI file null, if I am not mistaken. Yes, the first, where is that said? Yep. Yes, that's MPI final. Sorry, that's all in that text here. So that text specifies this behavior. So the IO error handling differs from communication error handling in another important aspect. By default, the predefined error handler for file handles is MPI errors return. The default file error handler has two purposes. When the new file is created, the error handler for that new file is set to the default file error handler. So I had this not in this notion. That's already there, but I make sure that we say everywhere that's the default file error handler. And IO routines that have no valid file handle on which to raise an error, open and delete, use the default file error handler. The default file error handler can be changed by specifying MPI file null as the argument to file set error handler. So just making sure that we clearly define what default means in all cases here. So we have a piece of changelog. So we say that we are clarifying the semantic of failures on error reporting during, before and during MPI init and after MPI finalize. And we specify that we added the MPI initial error handler info key to the reserved launch keys MPI compspawn on MPI exec. And I'll let you see this while I'm looking for the terms on the index. I'm going to go to the index after that. Okay, that will work. I'm sorry, it takes more time than I thought because the talk doesn't work. Yeah. I'm sorry it takes so long. Huh? So there is a lot of functions in MPI. Huh?
There's a lot of functions in MPI. This is a surprise.
No, it's not. But it's massive. Look at that. Okay.
I forgot we split them all out in the bindings. That does make scrolling take forever.
Oh well, I don't find them, so whatever. So we add to the index a bunch of terms. So the transmission failure term, the process failure term, and all of these terms are appearing under the error handling rubric. We also add the initial error handler term and the default file error handler and default window error handler terms, I believe. I really want to get there back to
yeah,
this.
You add, I'm looking at the diff on GitHub. You add initial error handler,
That's right.
reference it a bunch of times. Error handling startup, error handling finalize, process failure, and I think that's all. And basically just a bunch of references all over the standard to the places that you added them in the
Yep,
text.
that's correct.
this isn't the official reading, so if everybody doesn't see it, it's fine. We can make sure that everybody sees it at the March meeting. But for now, you can take our word for it that there's a bunch of LaTeX magic that puts this in the table.
So does anybody have comments on the general structure of this proposal, or somebody is unhappy about it, or wants to propose a much better way of doing it?
Aurélien?
Yes.
So I think the proposal is fine. I'm just thinking about the thing on the MPI finalize with the process zero stuff. It just feels strange to say that it's required for process zero to return, then add a note saying that it might not happen. I think it might be useful to add something that is required unless failures occur that process zero returns from MPI finalize, something like that.
Okay, so that's yeah, that's a good point. Okay.
Okay, that was my only concern from what I saw. I arrived a bit late, so I'm sorry for that. But otherwise, the proposal seems okay.
So any other notes? One of the things I took a decision on that on this is slightly different from what yeah, it's a decision that could be taken one way or another, is that we keep the attachment to MPI-COM self after MPI init. The idea is that if you have sessions, you never initialize MPI-COM self, so then you have only the initial error handler, and then you use the sessions error handler, so you are covered on that side. But if you do not, if you are using legacy programs, it is useful to be able to change the error handler programmatically, which MPI-COM self achieves. So here we get the best of, I mean, we get all of these possibilities open. So that's why I did that. So, but I wanted to know what people feel about that. I hear no hard feelings about it, so good.
So Aurélien, you skipped on page 383, you skipped the second half of the advice to implementers and said that you would come back to it.
That's right, that is right. Let's get back to this. And I skipped over it because we are discussing in the ticket itself about something that's related to that. Where is this? It should be here. Here we go. So we are in MPI init. We have an advice to implementers about, okay, if there are failures, maybe you cannot do what you want. And then we have a second piece of advice that starts here, which is a separate thing. When a failure occurs during MPI init, the implementation may decide to return MPI success from MPI init instead of raising an error. It is recommended that an implementation masks an initialization error only when it expects that later MPI call will result in well-specified behavior. That is, barring additional failures, either the outcome of any call will be correct or the call will raise an appropriate error. For example, it may be difficult for an implementation to avoid unspecified behavior when the group of MPI-COM world does not contain the same set of MPI processes at all members, or if the communicator returned from MPI-COM get parent was not initialized correctly. So the reason why I let you process the text a little bit before I go and talk. Okay, so The reason why we add this is because we want to have the possibility for implementation to delay errors if they are not relevant. So one example that Wesley came up with that is pretty interesting is you have some error that you detect during MPI init, some failure that you detect during MPI init that would prevent you from doing one-sided operations. However, if your program never creates a window, this is an irrelevant error that you never care about. So an implementation may decide not to tell you about the fact that it cannot do one-sided operation now, given that it will tell you when you create a window for the first time. Now there is the converse argument that if something went wrong, you might want to know immediately. And so another implementation may decide to return an error immediately because the user wants to know immediately, so that's the better option for that user.
Or you could have some way of configuring the two if you really wanted an implementation. I mean, you can't use info keys at this point because it's during a init, but you could have configure flags or MPI exec flags or whatever you might want to do as an implementation specific way of saying fail fast or fail conservatively. I don't know if those are the right phrases, but.
Yeah. So then that's the crux of the issue here. As you can see, this is an advice to implementers. So it is an advice. It is not standard binding. The reason why it is not standard binding is that this does not open new possibilities here. Even if we remove that text, an implementation is still allowed to return MPI success or MPI init and return an error later. The implementation does whatever it wants as long as it is matching its semantics. So when you do your send and you receive, you get your messages, fair enough. The fact that there is something else that's broken somewhere else doesn't matter at this point.
In the current standard, that notion is not entirely clear. The fact that MPI success doesn't mean that nothing has gone wrong in the background and MPI isn't just taking care of it for you. We had some text that we proposed in the earlier ULFM readings, if you're around for those, that address that. We're going to bring that back along with a couple of other sentences that you may have seen if you're looking at the pull request, and that'll be a separate reading that we hope to have ready for the March meeting as well, just to basically clarify what MPI success means and what it doesn't mean.
What is the defined behavior of MPI init that is observable by the user without calling a subsequent MPI function, which could then return its own error because it has its own semantics?
Well, the behavior of MPI init is that MPI initialize is true, and you are allowed to call another function without having undefined behavior. That's basically what it tells you.
Yeah, all the stuff that says you're not allowed to do this until MPI is initialized, basically. It may do nothing. Because we've talked about MPI doing lazy initialization, and I think OpenMPI
if all
even
subsequent
does some
functions, if all subsequent functions returned an error code,
okay.
because actually MPI wasn't initialized, I could set an internal flag so that MPI is initialized, came back with true if I wanted to, or I could just return an error code from it saying it's not really, you know. Actually, there isn't a huge amount of observable behavior from MPI init. Is there a situation? I mean, obviously, MPI might choose to return an error, but there actually isn't any observable, you know, semantics that you could breach, particularly in MPI init. It doesn't do anything to its parameters. You know, it itself is basically, you could do a no-op, and that would be fine. Just return MPI success.
That's correct. So MPI init might very well be implemented as a no-op and doing all the initialization during the first MPI send. That's a valid implementation if you can pull it off.
Yeah.
But if you have a very conservative implementation that does all the initialization and wire up and whatnot during MPI init and creates MPI COM world and something bad happens, it's also perfectly valid to say MPI has decided that you can't continue. You may argue with that decision, but it is in the implementation's purview to do so.
Well, I'll tell you that MPI has decided that it reports to you something wrong happened.
Right. Well, I mean, it could go either way. MPI could decide it's a catastrophic error and explode. MPI could decide that it's a non-catastrophic error and return an error code, or MPI could just mask it and say, this isn't a problem with MPI init, and you'll find out about it later when it matters. So you could go any direction, and all of those are legal.
Should we make a determination about which one of those is high quality?
I'm not sure. There was really a discussion about. So some people are really adamant that returning an error as soon as possible is high quality because it saves wasting time on your allocation, which is true. And some other people are adamant that it's a high quality implementation when it doesn't bother you with stuff you don't care about. If you're never going to use Windows, the fact that RMA doesn't work, whatever.
Right. So I think the only one that we can agree on is that it's a low quality implementation that just blows up during init for any reason.
Yes. Okay.
Yeah, if it doesn't even trigger the error handler, I would call that a low quality implementation. If it just calls, exit,
It's a fatal thingy. Yeah.
signal 9.
Yeah. Should that be made clear?
I mean, we could. I don't know that it adds something to say that if an MPI implementation doesn't bother to implement error handlers, it sucks. I don't know that that's a useful
Actually,
thing.
that's already written somewhere else.
So I'm thinking in particular of people like Jeff Squires who say that that MPI init being such a dangerous function, it might just destroy the process and take down everything connected to it. That's a dangerous function, and so none of the Cisco people want to use it because of that, right? So if we made it clear that that was a low quality implementation, and therefore the major implementations which want to be high quality will do something better than that. They will avoid blowing up in init. That immediately, it certainly encourages that to be fixed, and therefore encourages a whole slew of additional users. We don't mandate it and say it must not fall over during MPI init, because that would be stupid. But we're strongly encouraging it to, if it blows up, then it really is an absolute exception. That's a low quality implementation if you can't handle it at all. You should make a best effort, or some sort of wording along that might actually alleviate some of the fears.
Yeah. So I think the entire effort that we're proposing here is kind of the nudging in that direction. So we say that you are able to set the error handlers to something that is non-fatal during MPI init. And we say in the advice to implementer that, okay, sometimes the failure is too bad that you cannot do it. This is what we say, in which case the implementation may be incapable of providing the desired error handling behavior. But there is a clear nudging here that you should be doing what is desired, not just abort randomly.
Okay, that's fair. Yeah, if I ask for something like errors return, then try your best to do that and only blow up when it's absolutely necessary. Yeah, fine.
Okay, so
I was trying to find the text we added at in our previous proposal, where we were saying that MPI.
So that text was slightly different. It was not saying what MPI success means or doesn't mean. It was saying what you should expect on your output parameters on buffers when you have.
No. I meant in relation to what Dan was saying about a good MPI implementation should use error handlers as much as possible, essentially, as opposed to just aborting. I thought we added some in our previous thing where we talk about non-catastrophic errors.
In the beginning of.
Yeah, it's in chapter 2 somewhere.
Yeah, somewhere in there in chapter 2. So anyway, I don't have anything else to present for today. I think we are going to read this with minor modifications that have been discussed today. And hopefully we'll also have a reading for the definition of what success and non-success mean on the semantic of operations as a separate ticket.
All right.
All right.
So just about at the top of the hour, I think we can go ahead and wrap it up if there's no other comments.
All right. So thank you very much for attending and for the comments. And see you in 3 weeks from now, yes?
Thanks, folks. We do, I believe we have another one of these calls next week. I have to confirm with Puri. And we're going to talk about the terms and conditions discussion that he's been doing. So look for that on the meeting's website to confirm. And if so, we'll meet next week. And if not, then we'll have the face-to-face in 3 weeks. Thanks, folks.
Okay. Well, thank you, Aurélien.
Bye.
And see you guys. Bye.
Bye.